Good morning. We're the Silicon Slabbers, and we'd like to introduce ourselves. This is Vanshika, Nishat, Casey, Steven, and I'm Josiah. Our sponsor, Telefirma, offers a preventative slab procedure that raises home foundations off the ground, suspending them in the air to create a protective void underneath, designed to mitigate foundation damage caused by expansive soils. While the current manual process takes a team of men an entire day, we've designed an automated feedback control system that drastically increases the efficiency and accuracy of the lift while decreasing the required man hours.
So with the strict 3mm precision along with the limited budget, we were able to create a prototype system using a Raspberry Pi, 2 Arduino Megas, and 4 ultrasonic sensors. The sensors are connected with the Arduinos to both the sensor and the Raspberry Pi, and the Raspberry Pi to the Arduinos. The wiring is done with RJ45 cables with Ethercon cable connectors and the appropriate chassis connectors.
So as you can see in the diagram, the Raspberry Pi, which is our hub, is placed off the slab and hosts the feedback controlled software interfacing with the on-slab Arduinos. The communication between them, we've chosen it to be RS485, which will aid over long distances. In our prototype, we've used the Arduino, which communicates with the sensors and the actuators using an echo trigger system, and the hub, which is the Raspberry Pi again, connects with the server and uploads the data to Google Cloud Platform before being displayed or controlled through our web application.
The next step was to design the feedback control software. After understanding and modeling the dynamics of the slab lift, we developed an output observer-based, robust feedback controller. We chose to implement our optimal linear quadratic regulator as a discrete time linear system written in C. Using classic control techniques, we developed a highly damped MIMO system capable of real-time measurement and correction to lift the slab and stream data to the cloud.
The web application is how the lift manager and team track the progress of the lift and send user input commands such as start, stop, and lower. The user enters a desired lift height and hits a start lift button to begin the lift. A stop command can be sent to pause the lift or completely shut it down. Error messages are sent to the user if data is lost or cannot be provided, demonstrating the robustness of the system. The slab display shows the height of each sensor as the lift progresses, and color coordination is used to tell the lift manager when the slab is finished or if it's in an error state.
So basically our system would reduce manpower by 50% and the lift time by 75%. Telefirma will start seeing its profits within a year. We have also achieved 3mm precision in our lifts. We have also achieved an automated slab lifting mechanism through our web application, and also we have a scalability of 500 peers. We have also tested it continuously for its robustness and correctness.
We're Team 784. Thanks for listening to our presentation. We'd love for you to stop by and see our prototype at our poster, as well as our final design that Telefirma will be implementing this coming year. Thank you so much. We'll open the floor for questions.
If I was having my slab lifted on my house, I'd really like to make sure it wouldn't break. So what kind of safeguards have you built into the system that, like, if something really bad happens, automatically, keeps my slab from breaking?
Yeah, that's a great question. So this whole process is meant to happen before the house is built on the foundation, and you want to make sure that there are no cracks or anything. Telefirma provided us with a lot of specifications of how much deviation they would allow before any cracks happen or anything bad could possibly go wrong. And our system has, the software that we wrote has quite a few redundancies to prevent any sort of deviations greater than ½ an inch, which would cause cracking, to even be possible while we're lifting. And then after it's lifted, this project is a joint project with the mechanical team, and they've designed mechanisms that lock in place and should be able to allow for the foundation to be suspended continuously and for minor adjustments to be made very easily after it's lifted. Yeah.
Describe your discussions with your mechanical team if this is a cross-functional project. What are the key things that you've had to keep coordinated?
That's a great question. We had to work on where we're going to place the sensors, what kind of actuators we're going to be using to make sure that we have, because we have to do some selection of the hardware as well as they do. Those were the main key things that we have. They have a very robust design that should do a great job at holding it up. Does that answer your question? Okay.
So if you were to productize this, or if you have taken this back to Telefirma, are they planning to productize this and use this? or what are the real world challenges that they see that is not yet addressed?
That's a great question. They are planning on utilizing this with their actual lifts as soon as we finish it off and send it out to them. The problems that they'll face are scaling it up to larger sizes of houses. Some houses have larger slabs. We have our system being very scalable, and the problem there is, or the issues that need to be addressed is really just fine-tuning the software to be able to control how many you have, and connecting and disconnecting the amount of sensors and actuators that you have in your network at a given lift.
Can you put the, especially for the wiring, can you replace it with wireless connectors so that you can put these underneath and you can measure it up?
So we considered that. The problem is in your case, when you mentioned about putting it below the slab, the concrete is way too thick, so we just can't get a signal. We researched about it last semester. Anything beyond 6 inches is just not readable. We thought about putting it on top. A lot of options were RFID. There was actually a research paper saying about drones and RFID. But the problem with that is that the zone is a bit too big, and we want accurate positions. So it was just not viable at the time. And we want very quick, because the slab is lifting, our specification was 3 millimeters. So we needed very quick readings from the sensors. So wireless was just not really possible.
Moving forward, I think that's something that Telefirma is planning on looking into as well, because the type of actuators that we went with are self-contained. So having it all self-contained would be a very easy solution, assuming that we can get a really robust wireless network in place with everything connected.
To
Yeah.
also add on, they have a patent for the slab lifting mechanism, which cannot be obviously duplicated by any other company. So yeah, we are helping them with that.
All right, let's thank the team.